Okay, since we have a lot to cover today, I'd like to start the webinar. So yeah, thank you everyone for joining in today. This is the KiboCUBE 8th round announcement of opportunity webinar, and we are pleased to have you all here. Now, before we begin, please use the chat box to ask any questions and do not raise your hand. We won't be able to activate it. But if you have any questions, don't wait until the Q&A and please throw them in the chat box. Our colleagues at JAXA and of course at UNOOSA can answer the questions in the chat. So if you have anything, write it before you forget it and throw it in the chat. And second, please answer our questionnaire before you leave. We will put the link of the questionnaire feedback form in the chat box as well. So make sure to answer that before you leave. We would really like to hear your feedback on the webinars. And last but not least, please use the hashtag Access to Space for All and KiboCUBE. Please follow, like, and share the content we have at UNOOSA. We're active on Twitter, Facebook, LinkedIn, and Instagram. So today you are all here to learn a bit more about KiboCUBE. Just to give you an overview of KiboCUBE, it is a long-lasting partnership we have with Japan Aerospace Exploration Agency, JAXA, which started in 2015. And the aim is to provide educational or research institutions from developing countries and economies in transition with the opportunity to deploy a 1U CubeSat from the Japanese Kibo module of the International Space Station. And through KiboCUBE, 5 CubeSats have already been deployed, the first of Kenya in 2018, Guatemala, in 2020, Mauritius, in 2021, Moldova, in 2022, and earlier this year in January, we deployed the CubeSat of Indonesia. And we have 3 CubeSats that are under development right now from Sika, Mexico, and Tunisia. And this time we are looking for 2 more teams that will join us in the whole KiboCUBE family. Just to give you some ideas of what you can do with KiboCUBE, I will be introducing the past awardees of KiboCUBE. So as I explained, the first round was awarded to Kenya, the University of Nairobi, and their objective was to monitor agriculture and coastal areas. I just want to emphasize that all of these CubeSats, all of these missions have been partnering with other entities. So I really recommend and emphasize that when you submit an application form for KiboCUBE that you find partners that could help you realize your program. So in this case for Kenya, they worked with the University of Rome in Italy, and the achievements were amazing. They were able to download more than 300 images, surpassing the initial expectations, and it accelerated the creation of the Kenya Space Agency, which led to more participation of Kenya Space Agency and other access to space for all opportunities. So this way you can use this 1U CubeSat opportunity as a stepping stone to start your space activities. The second example is from the second round, Guatemala. This was Universidad de Valle de Guatemala. Their objective was to test the acquisition of Earth observation data. And as you can see, they partner with many different universities for their testing and manufacturing as well. So yeah, this team was also amazing in the sense of the satellite was in operation for 211 days with a lot of data packages received, and it involved more than 100 students in the project and developed 70% of the CubeSat in-house, which is pretty amazing. And they conducted successful outreach activities involving the media, workshops for young students, and especially girls, and publishing books and documentaries and all that. The accomplishments of this team, especially in the media outreach, was explained in the Access to Space for All expert meeting, and they participated and explained there. So I think that will be some interesting presentations that you can look at later on. The third round was awarded to Mauritius. The institute was Mauritius Research and Innovation Council. Their objective was to collect images and to test onboard communication. And they worked with the industry. So they worked with SSC Clyde Space. And as one of the small island developing nations, they were the first to develop a CubeSat, and they were able to download images of Mauritius and neighboring areas. So the photo you can see on the right-hand side is actually a photo taken by MeerSat-1. And they also conducted successful outreach activities involving the Amateur Radio Society and providing antenna workshops as well. So please, yeah, look at their websites as well. The fourth round was awarded to Moldova, the Technical University of Moldova. This was launched last year in 2022. Of course, the results are going to, we'll see more of the results coming in soon. But yeah, this was also a successful partnership with the Romanian Space Agency for their testing as well. And they were testing the technology demonstration in various modules and subsystems of the CubeSat. And last but not least, this is also a third round awardee, Indonesia, from Syria University. Their objective was to demonstrate the technology of communication between an automatic package reporting system, payload, and the ground. And their partnership was with their space agency, so the Indonesian space agency, LAPAN, now called BRIN, and we just deployed it in January. So we will see a lot of results coming from this team as well. So all of the teams I've mentioned, and of course the teams that are developing, they have a lot of things going on, and you can find a lot of information from them from our awardee page. So when you go to the top of Access to Space for All and click awardees, you will find a list of the different programs. So not only KiboCUBE, but other ones, but click KiboCUBE awardees, and then you will find a list of the awardees where you will get to access more information. And I think it will help you when you're forming your ideas to see what the past awardees have been doing. Also, just to give you an idea of what you can do, I'd like to emphasize KiboCUBE Academy. This is an online educational series that we have been partnering with JAXA and UNOOSA for, and it is really to provide theoretical knowledge to develop, operate, and utilize small satellites. So as you can see on the right-hand side, we have a whole list, amazing list of contents of pre-recorded lectures that you can access now. We have the presentations and the YouTube videos there. So please have a look. It really covers everything you need to know about KiboCUBE when you apply to KiboCUBE. And I will be referring to the KiboCUBE Academies a lot later on in the presentation. So when you're done with this webinar, please have a look at all of them in the presentations. I think it would help you a lot. And in 2023, we will be having more more KiboCUBE Academy webinars that will help you. So later on this next month, Friday, 21st of July, we will be having a KiboCUBE Academy webinar on the topic of CubeSat technology and CubeSat launch and operation. That will be online, so you can connect and ask questions to the professors. So that will be a great time to engage with us. We will also be having one on-site in Baku in line with the International Astronautical Congress, IAC. So if anyone is thinking of attending the IAC, please consider and reach out to us about this KiboCUBE Academy on-site workshop. Also in the middle or end of October, we will be also doing a KiboCUBE Academy webinar online, and it will be really about final tips on how to build a strong application. So I think it would be beneficial that all of you join that. And we are also thinking of doing technical consultation session. We will release all the details and open call in July, but I think we will ask you to send in perhaps a one-pager or a list of questions, and then we will set technical consultation sessions with JAXA and UNISEC so that you can throw the questions at us. If your CubeSat is feasible, if you have any questions in certain subsystems, if you have any questions regarding the J-SSOD, you can ask us there. So we will release the details in July. So please keep watching out for the information that will be posted on our website and also on social media. So with this, I'd like to give the floor actually to JAXA now to give an explanation about the International Space Station, the Japanese Kibo module, and the J-SSOD, the deployer, so that you will have a better idea of what you're going to be involved in. And then after that, I will be explaining a bit more in detail about how to apply, so about the documents that you need to read. So with this, I'd like to invite to the floor Mr. Fujita from JAXA. He is an engineer at the Kibo Utilization Center, and he will be giving you an overview of all the things I've mentioned. So Fujita-san, you have the floor.
Okay, I start. Hello, everyone. Thank you for coming today. My name is Tatsuhito Fujita from JAXA, and I'm engineer for J-SSOD team. In this screen, I'm going to talk you about overview of ISS Kibo and J-SSOD. Okay. First of all, I introduce of JAXA. The Japan Aerospace Exploration Agency, JAXA, was born through the merger of three institutions, namely the Institution of Space and Astronautical Science, IDAS, National Aerospace Laboratory of Japan, NARU, and the National Space Development Agency of NAST. It was designated as a core performance agency to support the Japanese government overall aerospace development and utilization, JAXA. Therefore, can conduct integrated operations from basic research and development to utilization. I'm showing the representative project here. We have some mission, for example. Today, I would like to explain about one of human space activities missions. It is CubeSat development mission. International Space Station is a huge manned construction located about 400 kilometers above the Earth, and it is circles around the Earth at the speed of 90 minutes per orbit. The ISS project aims at improving science and technology to enhance life and industries on the ground. 15 countries are participating in the ISS project, including NASA, Russia, ESA, Canada, and Japan, JAXA. Okay. Japan has completed the human space facility, the Japanese experiment module Kibo, and train astronauts who will operate the ISS and Kibo at JAXA. Kibo has a pressurized module and exposed facility. So a variety of missions can be conducted both inside and outside Kibo. At the Kibo exposed facility, there are a lot of unique systems. It has an airlock that allows payload to be moved from inside to outside the Kibo. And the small robotic arm, it called a remote manipulator system. So many missions can be operated at the Kibo exposed facility. One of them is James Small Satellite Orbital Deployer. It called J-SSOD. JAXA developed this unique system to deploy the satellite and inject the orbit from Kibo. Okay, this is the image. So this table shows the specification of J-SSOD. The satellite size is defined as a unit, and 1U is a cubic of 10 centimeter. 10 centimeter. The J-SSOD can be released up to 6U satellite, from 1U to 6U satellite. And 50 class satellite can also be released, even though one size of satellite is limited in KiboCUBE. Okay, the ISS is moving in the direction of the plus x-axis, and the satellite will be deployed 45 degrees backwards for the direction in which the ISS is moving. The maximum deployment velocity is 1.7 meters per second, and the speed changes depending on the mass of the satellite. For the development mechanism of J-SSOD, there is a big spring inside the J-SSOD case, and then separation mechanism set on the outside of the case. As the satellite is loaded, the big spring is compressing, and the satellite are kept in the case by the door. When the separation mechanism receives a command for release from the ground, the separation mechanism move and the door is opened. Finally, satellite in the case are pushed by spring and deployed. There are two types of case that can carry satellites the size of CubeSat. In the J-SSOD case, the satellite is set to the case on the ground, and the maximum size is 3U in the slot. While in the J-SSOD case, the satellite is loaded into the launch case and transported to the ISS, where it is stored in the Kibo module In the Kibo module, the satellite will be transferred to the development case by astronauts. So the J-SSOD can be used repeatedly and can release max 6 satellites in a slot. In addition, although not shown here, there are special cases for the wide 6U size and 50 kilogram. Next, I explain how the development satellite will be transported to space and deployed. First, the developed CubeSat is installed on the J-SSOD case, okay, and then packed into the cargo transfer bag. Then they are transported to NASA and launched as pressurized cargo by rocket. Because CTB bag, the vibration environment is lower than that of the rocket. Okay. Let's show the movie. So after the J-SSOD case arrives on the ISS, astronauts mount the J-SSOD case on the platform. Okay, right now, and then the platform is carried out of the ISS through the airlock. This one, airlock. And then the robot arm carries it to the development position. Okay. So now the satellite will be deployed like this. Okay. So operation commands to move the robot arm and to deploy the satellite are sent from the ground. Flight control team and engineer team are in perfect condition and support deployment from the ground. The size of the satellite is small, but the mission is made possible by many support members. In this slide, I would like to introduce a few advantages of small satellites compared to large ones. Small satellites are attracting considerable attention because of their short-term and low cost development. They are suitable for first-time users as a first step toward developing a large satellite to solve social problems. Since the development cost is low, small satellites can be used as an educational tool and challenging missions. And then small satellites can be developed in about 1 to 10 years. And about 1 year of operation is expected. Therefore, even college students can experience the full process of satellite development and operation. And the user can get quick return on your business investment, technology demonstration, and so on. In addition, practical remote sensing data can be obtained from small satellite. It means sufficient data can be obtained even with low cost and short-term development, which is a great advantage in terms of cost effectiveness. Finally, I introduced the achievement for J-SSOD. J-SSOD operation started in 2012, and this year marks the 11th year. JAXA have continued to provide development opportunities. So 72 satellites from 31 countries have been successfully deployed from the J-SSOD. As you can look at the world map, we are releasing satellites from all over the world. Regardless of region, also, 5 of the satellites selected by KiboCUBE have been successfully deployed so far. We are hoping to see many institutions apply for the 8th round of the KiboCUBE and explore their possibility of space utilization. JAXA is looking forward to supporting your challenge. Okay, my presentation is finished. Thank you.
Thank you very much, Mr. Fujita, for the presentation about Kibo and J-SSOD. I think that was a lot of information, but it's really interesting. And for everyone here, you can download the presentation already. It is on our website and the recordings. So this webinar is recorded, and we will definitely put it up soon after the webinar so that you can see it again. So thank you very much, Fujita-san, and I'd like to move on to actually talking about the documents that you need to read for this. Now, I'd like to move on and talk about two documents, basically the announcement of opportunity document and the application form. But first of all, I want to explain where you can find these documents. Now, because all of you are already here, I believe that you know how to get there to the KiboCUBE webpage. I must say the easiest way is this: type in KiboCUBE, and you will find KiboCUBE rounds. That's where we want to get to. But I will also tell you the long way, which is to go to the UNOOSA website, and then you will easily find an icon that says Access to Space for All. So please click Access to Space for All. Then please click on the Satellite Development track. KiboCUBE is organized under the Satellite Development track. So you press Satellite Development track, then it will take you to this screen that you have on the right-hand side, and then you click KiboCUBE. Now here, under the education component, you will find the KiboCUBE Academy webinars and the KiboCUBE webinars. So those are important things for applying to KiboCUBE as well. But first of all, let's just push KiboCUBE and jump to that page. It will take you to this page that you see on the left-hand side. You need to scroll down and then press on the rounds page. So this page is extremely important. This is actually the only place where we will be updating the information. So basically, all you have to do is just check this web page. Now, I have the tips on the right-hand side. It says, read all the documents carefully, and I cannot emphasize this enough. All of the documents on this web page are so important. I would really like to ask you to read all of them carefully. The second point is join the upcoming KiboCUBE Academy live sessions. I've explained the dates earlier, but all the new information, the registration will be posted on this website. So please keep checking this website for the new KiboCUBE Academy live sessions. And the third point is watch the on-demand pre-recorded KiboCUBE Academy webinars that I explained earlier. Those webinars are the short webinars, the short recorded lectures that you will find, and I will be referring to a lot of them. And of course, you will need to submit the documents on time. But basically, yeah, just to go over the documents that are there. From the top, it's the announcement of opportunity. I will explain that more in detail. The second one is the application form. Of course, you will need to fill that out. The third one is one of the most important documents. It's the GEM Payload Accommodation Handbook. I just want to emphasize, sorry, this is an old image, but we updated, JAXA updated the handbook, and now it is version E. So the website is right. Sorry, this image is something a bit old that I took a week ago, but on the website, you will find version E. So please refer to version E and read that, because that is the actual handbook, the technical handbook that explains everything about the deployer, what size it has to be, the safety requirements, everything. So this is I would say one of the most important documents of KiboCUBE. And the next document is, of course, something you would need to read as well, and of course, the reference material. So I won't get into all of the details right now, but I just want to emphasize these are all really, really important. So this is what the schedule looks like. You're here on the 22nd of June, so for the announcement of opportunity webinar. After this, as I mentioned, we will have more KiboCUBE Academy live sessions during the summer. And by the end of the year, on the 31st of December, you would need to submit your application form. So that is your goal. And after that, so in 2024, we will be going through the selection. So JAXA and UNOOSA will be reviewing all of the applications that we have received, and we are targeting to announce the shortlisted entities in February. So basically, we will shortlist 2 teams. So if you are shortlisted in February, you will have another 3 months. We will be conducting an interview. You will need to submit an updated application form, and you will need to review and confirm the legal agreement. So you will need to do 3 things. As I said, interview, update, and submit the application form, and review the legal agreement. And when that has been confirmed and we see that your team is feasible and ready to go, you will be selected as the final awardee in June 2024. And from there, the long development and road to deployment begins. So basically, we target the teams to be able to finish their deployment between 15 and 18 months. For this opportunity, the launch is scheduled for 2026. So you will have the rest of 2024 and 2025 to go through the development. Of course, the development has a lot of stages. It has the development stage where there are many different safety reviews you would need to go over. And of course, the handover and transportation phase, and then the launch and deployment phase. So this is all explained in the announcement of opportunity document. Please make sure to read that. But you can see that there are many steps before your CubeSat will be actually launched. So yeah, just to go over the handover and transportation phase, this will happen 3 to 4 months before it is launched to the ISS. So you will need to bring your satellite or send it to JAXA, probably Tsukuba Space Center, 3 to 4 months before it is able to be launched to the ISS. And then after that, JAXA will take over and they will be sending it to wherever it is going to be launched in. So in previous cases, it has mostly been by the US. So JAXA will send it to the US and then it will be launched from there. And then the deployment will happen between 1 and 2 months after the launch. So your schedule looks like that. And of course, for CubeSats, it's not only the deployment. From there, you actually have to operate the CubeSat and get the data or technology demonstrate the technology or whatever your mission was. So you have a post-deployment phase after that. And then in the end, we will be asking for a report. So there will be a reporting phase. So although in this graph, 2025 and 2026 look a bit small, it is actually more extended and there's a lot of things you would need to do. And in the meantime, on the top, it has the outreach and publication phase. So from the moment you're selected as an awardee, please use this opportunity to conduct a lot of outreach, publish papers at international conferences, and really maximize the opportunity. So KiboCUBE is a capacity building opportunity. The main objective for us is really for the teams, for the country, to build capacity in space. So really, we would really like to ask you to maximize this opportunity, not within the university, just within the university, but do workshops, really have talking engagements to really motivate the young generation and also to have more people understand the importance about space. So yeah, please read the announcement of opportunity document for the details, but this is what it'll look like. I'm just pinpointing the important parts of the document. So yeah, the next part is the eligibility criteria. Please have a good look at this, but I want to emphasize that the entities that are eligible are the ones that are located in developing economies and economies in transition. If you are not sure which classification your country belongs to, please look at the document, the World Economic and Situation Prospects Report by the UN. We have the link in the announcement of opportunity document. And yeah, you will clearly see that there is a list and you will understand where your country lies in this. The entities that are eligible are the government organizations, research institutes, universities, and other public organizations. However, I just want to emphasize here that we are welcome to partnerships. So if you want to work with an entity that is not eligible, you can. We're not saying no to partnerships. However, they cannot be part of your team, so they will have to be someone as external support. So in the application form, there's a clear distinction between your team and external support. So if you are going to work, let's say, with a space agency from a spacefaring nation or a university from a different country, don't put them in the team, put them in external support. I really emphasize this because some people get it confused, but the applying entity must be someone who is eligible. And the team members, we can actually accommodate as many members as you deem necessary. So it can be a team from, I don't know, I would say at least maybe 3 or 4. That would be minimum. I haven't seen KiboCUBE teams that are smaller than that. And to the maximum, how many members as you may need. So that is up to you. The next is the selection criteria. This is what we will be looking at when we score you. So please have a good look at this part of the document. I think it is, yeah, written pretty clearly, but it's really the completeness of the application form. Let's say if there's too many TBDs, we will not be able to understand your proposal. So that has a low score. We would really like to have as much information as possible. And of course, the scientific and technical value of the CubeSat mission as determined in A or B, the novelty of the mission. So we don't want another, let's say, random satellite that's part of a constellation. We want a mission that is novel. So please make sure to emphasize that in your application form. We also need to understand that the team is able to demonstrate that they have the capabilities the capabilities to actually develop the intended design and function of the CubeSat. And yeah, that the mission of the CubeSat is for peaceful purposes, of course. Yeah, and then we have the link between the CubeSat and the Sustainable Development Goals. I'll be explaining that earlier, but yeah, the other ones are to be compliant with the different international guidelines and treaties that I will mention later as well. Of course, the compliance with the program schedule. So for this one, we would ideally like to deploy it in 2026. So please make sure that your schedule is fitting that. If you want to deploy in 2028, well, that is not going to work for this round. So please make sure to plan accordingly. And of course, the outreach and communication that I've mentioned earlier. So please have a good look at this document as well. The next one is the roles and responsibilities. So this page really explains what the awardee, so the selected team, will need to do. So basically for KiboCUBE, what is provided by JAXA is the launch and deployment. So everything up until then, the team has to pay for the cost and be responsible to do everything. So that is explained here, and please have a good look. I think it's clear what you would need to do. And I think this is, the next part of the same section. So there's a lot of things, but please make sure to review that as well. And I just want to emphasize again that all costs related to the preparation, so the developing of the CubeSat, the testing of the CubeSat, transportation to Tsukuba Space Center in Japan, the shipping, and any insurance related to that, any personal costs that may arise from that, and all the outreach activities, these costs must be borne by you, so the awardee team. 15 is the terms and conditions. Please read this part closely as well. And as I've explained, after you've been shortlisted, we will be providing you with a bilateral agreement to be signed between JAXA. So you will have access to that document when you're shortlisted, and you'll have 3 months to confirm and review and confirm the contents. So you will have time to actually discuss that as well. So I just wanted to mention that. Okay, now we move on to the application form document. I really recommend that everyone has it with them right now. It's already downloadable on our website, but I'm going to go over them in detail. So the first part is team composition. It's really, I think it's very straightforward. You really need to summarize in the executive summary why you chose to perform this experiment. So this, why you want to do this mission, what are the expected outcomes, why it's unique, and basically your plan on how to do it. I also want to emphasize here that 1.3 is a certificate page. And besides the certificate, so the certificate page, we ask you to have the top person, so the head of your entity, sign the document as a certificate and also stamp it. This is the certificate. However, we also ask for a letter of endorsement from each of the organizations. So this is not the same document. It is 2 different documents. So you would need to have the signed certificate, which is part of the application form, and a letter of endorsement. So there is no template for this letter. It's basically telling us that the university or the research institution, whatever you are, is supporting this application. So we would need those 2 documents just to emphasize and explain. The next part is the team composition. I'd like to explain again the team members and the external support. So the difference between 2.1 and 2.4. So in 2.1, you put in the description of cooperation, and if it's a joint proposal from several entities, so University A and B that are both eligible, you write the contents of the cooperation there. However, if you're University A and you want to work with Company B is not eligible because they're a company. So in that case, you will write about your cooperation under external support. So as I have in the blue box here, 2.1 is within the team, 2.4 is with external organizations and individuals. We have some people that mix this up, but please be careful because people within the team are only people who are eligible. So the moment you have someone that's not eligible, yours will not be scored. So please be careful with that. Chapter 3 is the technical abstract. So basically it's an abstract. Please explain what your CubeSat aims to do, what kind of value it will bring, the overview of the design and related segments. So it's like the mini version of your whole application form. So of course there's a word length, so make sure that it fits that. Chapter 4 is the mission objectives and requirements. 4.1 is the mission statement and contribution to capacity building and objectives. Those two images are from past KiboCUBE awardees. This is not the exact context that they had in the application form, but I'm bringing them as examples as these were presentations from the past. So it's really how the development and deployment of the CubeSat could contribute to capacity building in your country and really what you want to achieve through the project. And please use SMART criteria, which is specific, measurable, achievable, realistic, and time-bounded. We really want to understand what you're trying to do and make sure that it's using these criteria so that we get a better understanding. Okay. 4.2 is the foreseen outcomes and deliverables. So we ask you to insert a description of the specific outcomes of the CubeSat mission and how the outcomes and its related activities contribute to one or several of the Sustainable Development Goals. So basically, KiboCUBE and the many opportunities of access to space for all, we contribute to SDG 4, quality education, 8, decent work and economic growth, and SDG 9, industry, innovation, and infrastructure. But I believe a lot of the missions that you will bring in will have different applications that will be able to be linked with the different SDGs. So there's 17 SDGs, each of them have targets and indicators, and some of them, some of your missions might be able to link directly to one of the targets. Maybe not the indicators because they're very specific, but at least the targets. So please have a look at the UN SDGs page, which I have put the link to, and probably my colleague Wenbin has already shared. And yeah, please review them because this is really important for this section, but also the outreach section. And of course, as I've mentioned earlier, our awardees have done this exercise already, and you can find more information on the awardees page. 4.3 is novelty and uniqueness. As I've mentioned, is your CubeSat just another satellite in the constellation? No, we don't want that. We want unique and, in a sense, new and unique CubeSat. So please explain how it differs from similar CubeSats and what is the difference if you had a CubeSat in the past. What is the difference with the previous missions? So here, and also the technical heritage, we want to understand why your experiment, why your CubeSat is special, and if you have the capabilities to do it. So basically, you're trying to try to convince us why we should choose your proposal. So these sections are important. 4.5.1 is the mission requirement. So now we get into a bunch of requirements. The mission requirement is requirements related to task, function, or constraint, or an action induced by the mission scenario. And we ask you to provide a list with primary and secondary requirements. So the primary requirements are the requirements that need to be met to accomplish the mission objective. So these are like the must requirements. And secondary requirements are something that is good to have. So if you actually are able to meet it, that's great, but it's a good to have, you don't have to. I put one example in mission requirements as the CubeSat shall take images of whatever target, how many times a day with the definition of a resolution. So you will have to give us requirements on what your mission will have to do. Of course, it should be a very long list, not just one. From our past KiboCUBE teams, I'm seeing a lot of requirements. It is the same for the CubeSat design requirements. This is where we ask for the requirements on the designs that are related to the construction standards, design standards, selection list of components, materials, so everything you see on the page there. And we would really like to have it verifiable and compatible with what is on the GEM Payload Accommodation Handbook that I've mentioned earlier. So you have to read the GEM Payload Accommodation Handbook. This is where it will be explained on what size CubeSat will fit the deployer, what kind of railings it has to be, what kind of things need to be in this direction, that direction. All of the details will be mentioned there, and it has to be compatible with the GEM Payload Handbook. So please read that. I've given a few examples there. Just to emphasize, the GEM Payload Handbook, as JAXA was explaining, the J-SSOD is open until 6U, but for KiboCUBE, it is 1U. So please make sure to propose for a 1U CubeSat. The next section is ground segments design requirements and user segment design requirements. For the ground segment design, it is mandatory, but for the user segment, if your CubeSat is not going to communicate with a user segment, it's optional. So you don't have to answer that if you are just using the ground segments, let's say. For the ground segments and ground systems, actually, I have referred to KiboCUBE Academy Lecture 17. Please have a look at this lecture and the presentation. I think it will give you a good understanding of what it is for what a ground system looks like and how to do the operations. The next part is the operation requirements. I've also put in the same KiboCUBE Academy lecture. Please have a look. Operation requirements are the requirements related to the system operability. And here we would like to ask you to include operation requirements for both the early orbit phase and the normal phase. What I mean by the early orbit phase is when the CubeSat is deployed from the J-SSOD. There is a lot of things that need to be done for the CubeSat to stabilize itself. So there are some operations requirements that will need to be for there. And of course, the normal phase after the CubeSat is stable, there are regular operations that need to be done. So please explain both of these types of requirements. Moving on to Chapter 5, it's the system specifications and detailed descriptions. It's really to understand what you're trying to design here. So the specifications, as you can see, please tell us how big it is, the size, how heavy it is, the 3D view on what it's going to look like, and the external dimensions. 5.2 is the system block diagram and list of components. I know it's a small image over there, but it's really to understand how the subsystems are related to each other. It will look like something like this, not too complicated, but of course not too simplified, because we need to understand how each subsystem links to each other. And 5.2.2 is the list of components. So I have an image there. This is not, this is an image, but we need to have up to the lowest level. So let's say in this image, it says camera, but if the camera has specific different parts, you would need to explain that as well. So we need, I would say this would be a pretty long list of the components to the lowest level available, and include whether this item is going to be made in-house. So if you're developing it or if you're going to purchase it, that's a totally different thing. So please mention that. And if you're purchasing it, please include which company, which vendor you'll be purchasing it from. So product breakdown structure will be highly appreciated. And if the component is made in-house, please provide technical readiness level, TRL. I hope people are familiar with the term of TRL. Maybe my colleagues can put it in the chat later on, but we need to understand how mature your component is. 5.2.3 is a subsystems design. I've put in a link to Lecture 7, Introduction to CubeSat Technologies. It really explains a lot about the different subsystems that we need to think about when we develop a CubeSat. And then from 5.2. From the following parts, we go into the each of the subsystems. Sorry, maybe the numbering is wrong for this one. Let me check later. But yeah, the first is structural and mechanical subsystems. The next one is electrical power subsystems. And for here, we really want to understand what you're trying to do. So please provide a list of components and provide as much detail as possible so that we understand how the subsystems are going to look like. So please take a look at the KiboCUBE Academy lectures that I've put on the right-hand side as well. I think it will give you an overview of each of the subsystems. So I can say the same for the thermal subsystems and the communication subsystems. And each of the subsystems have a description in the application form where we include the information of what we want to see in detail. So I think it's relatively clear. So the next one is command and data handling. I've put the links there as well, and attitude determination and orbit control systems. These are all mandatory, so please make sure to fill that out. 5.2.3.7 propulsion or deorbiting subsystems. This is optional because if this subsystem is different from the attitude and orbit control systems that you have, you would need to fill it in. If it's the same, you do not have to fill it in. The other parts are the payload. Of course, you need to insert a description of the actual payload. And if there's any additional technical features of the CubeSat that you feel that you weren't able to explain in the earlier sections, please provide it. If you feel like you've explained everything, it's an optional area, so you do not have to fill that in. The next section is the interface. As you can see, we've talked about the different subsystems, but here we want to understand how these subsystems are integrated into the CubeSat. So then each section, mechanical, electrical, thermal, communication. So it's really bringing what you explained in the earlier sections and explaining to us how they are connected. 5.3 is the concept of operation. So the satellite in a lifespan will have about 3 principal phases: the pre-mission, the mission, and the post-mission. So the pre-mission phase is where the deployment of the pre-mission phase starts after the deployment of the CubeSat from the Kibo module of the ISS, and will prepare the satellite to start fulfilling its objectives. The mission phase is where the satellite is, in normal operation mode, and where you will actually do the activities you plan to do to complete your mission objectives. And the post-mission section is where the satellite is no longer operating, or you need to decommission the satellite. So please give us an image of what you have for the concept of operations. And 5.4 is the communication links. You need to insert a description of the communication link budgets used by the CubeSat. Please refer to the elements of 5.2.3.4, which is the communication subsystems, so that we can see a clear link between these two sections. 5.5, 5.6, the ground and user. As I said, if you don't have a user segment, there's nothing to explain, so you can skip that as well, but the ground segment is mandatory. 5.7 is the safety. So for KiboCUBE and ISS deployment, what is really crucial is the safety, because these CubeSats are delivered to the ISS where there are people, and the people will actually be setting up the CubeSat into the deployer, like the video that JAXA showed. So there are very high safety standards, I would say, that you would need to follow. And all of this is explained in the GEM payload handbook. I can't emphasize how important this document is. Please have a look at that. And also, please look at the KiboCUBE Academy lessons that explain about the safety requirements, and also the safety review process. So there's a bunch of safety requirements, and then there will be a safety review that will make sure that you actually fulfill these requirements. After that, Chapter 6 is the verification and validation of the planning. So this is where we will be asking you how you're going to verify and validate the requirements that you set in the section 4.5 whatever. So make sure that when you set the requirements, that you have an understanding that you need to prove that and validate and verify that later on. So that's Chapter 6 would be that section. 6.2.1, description of assembly facilities. This will be asking you about the facilities that you would need for assembling the satellite. So maybe like a clean room. 6.2.2 is the description of the testing facilities. So there's various testing that needs to be done for a CubeSat. Let's say electrical interface, functional tests, EMC tests, end-to-end simulation tests, deployment tests, thermal tests, vibration tests, fit check tests. All of these are coming from KiboCUBE Academy, so please take a look at those. But there's a lot of tests that you would need to do. So please explain what kind of facilities you have access to. And 6.2.3 is actually, please explain to us if you don't have any facilities or you're looking for partners. That's also something we want to know. Of course, it's better that you have access to these facilities or you have partners who can explain that. But yeah, please explain to us all of the facilities that you will have access to and not to. Chapter 7 is planning. We ask for a work breakdown structure to really understand how the design, development, testing, operations, and decommissioning is going to go. This is a very important document, a part of the document, because this is where the feasibility of your mission is really going to come alive. So please make sure to fill this in carefully. 7.2 is the design and development schedule. This image is coming from KiboCUBE Academy as well. Lecture 3, please have a look. It explains the whole project management of satellite development. But yeah, 7.2, we are asking for a design and development schedule. The image should, the image should look something like the image here on the right-hand side. But we also ask you to include a critical path, which is the longest path in time from start to finish, and it indicates the minimum time necessary to complete the entire project. If you don't know what a critical path is, I think you can look it up. The definition I've written there, I think is clear, but you will need to make sure to include that so we can understand the whole development schedule and also the risks that will be related to that. But here we would really like to ask you for a Gantt chart. And yeah, this would also be a very important part where we would be really checking if your development schedule is feasible. If this is too over-optimistic, the chances are very low. We would like to see that you have considered a lot of the different aspects and also, let's say, the risks and failures, and that could happen. So we would prefer to have something more detailed than an over-optimistic, easy schedule. 7.3 is the operations schedule. So we understand that this stage, it might be difficult to provide a complete schedule for how you want to do the operations of the satellite, but please provide as much detail as possible what you need to do for mission operations. You can find more information on the KiboCUBE Academy lesson I have put there. 7.4 is the end of life and deorbiting schedule. So the lifetime of a small 1U CubeSat is about a few months and maybe a maximum a year. And in the end, it would need to fully burn up and when it's re-entering the atmosphere. So we would need to understand how you plan for that to happen. Yeah, and this is where the space debris mitigation guidelines and the guidelines for the long-term sustainability of outer space activities. This is also linked to the application form. This is where these two guidelines will be important that you read, because this is really where it explains how to be a responsible player in terms of the end of the CubeSat life. The only source of onboard stored energy on a CubeSat is the battery. So what you would probably need to do is explain how you have changed the commands in the battery to be passive, or there will be no other needs taken so that the battery won't recharge itself. So there's a few things you would need to explain here. Okay, and chapter 8 is budget. I'd like to say for the first part, so when you submit the application by December, you will need to give us a whole idea of the costs, but you don't have to secure the costs yet. We need to understand all the prices that are written there. So the price of the parts, the personal costs, the facility costs, the operation costs, travel expenses, shipment, insurance, everything. You will need to give us a list so that we understand that you understand how much it's going to cost you, but it doesn't have to be secured. But when you are shortlisted, you will have the additional 3 months to make sure that everything that you mentioned is secured. And 8.2 is the budget source and expected budget source, so where you will acquire the funding from 8.1. Now, I know that although yes, CubeSat missions are getting low cost, there is still some cost to it. We've seen many teams, let's say, work with governments or partners, but we've seen a few teams that have done crowdfunding as well to get more funding. So there are various ideas that you can put in and to get a bit more funding. So if you have any plans to do that, please make sure to explain that in 8.2. Chapter 9 is the transportation to Japan. Please provide information concerning the transportation. You would really need to check the customs and export control regulations for both your country and for entry of Japan. JAXA will support you in the end when this is actually happening, but we also want to see that you're prepared and you understand all the different documents and the preparation that needs to get into it. This is a very critical point, so please just don't say that you're going to send it through DHL. It's really not that easy. Please try to do your research as much as possible. And we can't give you a definitive answer because it really depends on which country you're sending it from. Or let's say you're developing it here, but you're testing in a different area, then there's a lot of transportation between that. So in Chapter 9, we only ask for transportation to Japan, but if you have any other transportation you need to consider, the research will be the same. So yeah, this is some difficult information that you would need to consider, but please have a look. Chapter 10 is the licensing and compliance with the international guidelines and regulations. I have put in the links, and also on the KiboCUBE round webpage, you can find links to the International Telecommunications Union website, the ITU websites, that explain about the frequency allocation process. Please take a look at their web pages. However, it is a bit difficult, so that is why we are scheduling a webinar with ITU in September 2023. Of course, you would need to start your research beforehand, but yeah, we have a webinar coming up in September, so we will definitely help you with that. But what you would need to provide is the timeline, so a plan of how you're going to acquire the location and the entities involved. So it depends on the country, who you need to talk to, which ministry you talk to. There's different organizations. So please, yeah, start your research. If there's any team or entity that has done CubeSat deployments or launches before you in your country, you might want to go up to them and ask them about this process, because it is, to be honest, it's quite complicated, and I recommend that you start as soon as possible. 10.2 is the space object registration. This is with us, UNOOSA. I put the links to our Register of Objects page there. In the end, this is an obligation of the government in your country. So it's not you that's going to be sending stuff to UNOOSA. You will have to go through a procedure of sending the information to your government, and your government will be sending us this information. So the same advice I have here is, if there's any team or any person that has launched a CubeSat within your country, go up to them and ask them if they have experience. If you're the first CubeSat of the country, great, you might be the first example. So in that sense, it would be best to reach out to the government as soon as possible regarding this. I'm happy to say we'll do a webinar about this in September at the same time with ITU filing as well, so that we can give you more information. The next part is the compliance to the Space Debris Mitigation Guidelines and Long-Term Sustainability Guidelines, the LTS guidelines. So I've put the links to each of the guidelines there. Please make sure to read these guidelines. They're not that long. And we did a webinar on the tips of implementation on these two guidelines in 2021. So please have a look. We have our colleagues that explained about what the guidelines are and how you can actually follow up on that. For the LTS guidelines, as you can see there, I've given it some examples. So the LTS guidelines have section A, B, C, D, and for section A, it's talking about the policy and regulatory framework in the country. So basically, what we would like to know is that you read section A and you explain to us about the policy and regulatory framework in your country. Section B, if you can explain how your CubeSat follows the safety standards that are written in the LTS guidelines. Some of them might not be applicable, some of them are, so please read the section B and tell us how it follows it. Section C, explain, it's a section on international cooperation, capacity building, awareness. So there you can explain how your CubeSat mission is promoting those things that are listed in the guidelines. And Section D, explain how you considered for your mission to be sustainable. So read Section D and then explain how you're in line with the direction of that. For the space debris mitigation guidelines, I've also put a list here of the information we need. For some parts, as you can see, it is not applicable, but for some parts, it's easily applicable and you can explain. So limit debris related during normal operations, explain how your CubeSat will not release extra space debris into space during the normal mission operation phase, how it's designed to minimize any risks. So I've put together the information you need there, so please have a look. But yeah, first of all, you need to read these two guidelines, and I promise it's really not that long and it's very clear. For related to that, we have a section under the webpage called Tools Components of the Satellite Development Track. There you can find a bunch of tools that will help you with not only the development, but actually the end of life and deorbiting tools. So they will give you, these are some tools that help you calculate and do the analysis of the reentry or the things related to what you would need to do in the space debris mitigation guidelines and the LTS guidelines. So please have a look. We're almost there. So 10.4 is Earth observation license. This really depends within your country. Some countries don't require this, some countries do. So please check your country's regulation if there's anything you would need extra for the Earth observation, and 10.5 other if there's any other things. Chapter 11 is the feasibility and risk analysis. We ask you to describe the risks that you might face, not only technical, mechanical, but also planning and budget risks. If you can use a risk matrix like the one you can see on the right-hand side, that would be great, so we can fully understand the severeness of the risk. And of course, if you have picked up the risks, then how do you mitigate them? That will be explained in 11.2. Chapter 12 is the communications and dissemination plan. We have two target audiences that we ask for you here. So the outreach to the general public and outreach to the scientific and technical community. So the general public is more of, let's say, the young generation, students, the governments, the people in your country. And the scientific and technical community is more of, let's say, the applications of the CubeSats, if it's a communication mission to the communication radio amateur network community, all that. So we've divided the outreach part. And these plans shall include the type of activities, the target audience, resources, so what you're going to do, how much budget you have for that, and the schedule. A great example is, I've explained earlier, we had the Access to Space for All expert meeting, and session 4 was on effective outreach. We had two amazing presentations from Guatemala and Mauritius talking about how they did their outreach. So I really recommend that you take a look at their website of their presentations as well. Okay, I know I talked a lot and that was a lot of information for you, but I think these points will be really helpful for all of you when you fill in the application form. So now I'd like to move on to the Q&A time. I haven't been able to see the chat much, but I think a lot of it has been explained. Sorry, let me try to check my chat. If anyone has any questions now, please put them in the chat box as well. Okay, I am seeing one question from Dadika from Namibia. What is the purpose of deploying the Kibo small satellite into space? Does it collect any useful data? So this question, I believe, was answered by JAXA, by Mr. Fujita in his presentation. So a small CubeSat, of course, it can't do everything, but it is the first step of a country to start their space activities. And with a 1U CubeSat, you can actually do many things. You can use it as an Earth observation mission, so you can take pictures of a certain area to actually monitor some aspects that you would like to do. So if you have certain cameras or certain radars or certain things that you can measure on the payload, you will be able to measure, let's say, water precipitation or the temperature, or it really depends on your mission. If you want to have a communication mission, it will help demonstrate the communication. So it really depends on what you want to do with the CubeSat, actually. But there's a lot of things you can do. I think there's a KiboCUBE Academy lesson mentioning that, so please have a look as well. And if any of my colleagues have anything to add to that, I'm open for all of you, my colleagues, to turn on your cameras and microphones and mention more. Sorry, I feel like we have a lot of questions. Maybe it's just me. Mine is loading slowly. There's one question about the cost budget. Could you provide an approximate budget for the total cost? Well, it would really depend on where you're buying the materials, the parts from, where you're doing the testing, how much personnel costs are. But I guess from the explanation by JAXA, nowadays CubeSats can be developed in the 5 million range. Was that correct? So we don't have a hard number for this, but I would say something like that. It was explained in JAXA's presentation. I'm trying to see the. There's one question about the respect to space law. For the register of the object, it will be your country that will be delivering and registering the satellite. For the frequency allocation, it will be done through yourself, through the country that is deploying the satellite. Sorry, the country that is developing the satellite to go through ITU for the frequency allocation. The launching state part, it's a bit complicated, so I would not answer it now. Maybe we can address it later on as well. One question, JAXA would finance the components to a certain budget. No. So as I've explained, all the costs related to the development of the CubeSat will be borne by the team. JAXA does not pay for anything. JAXA is going to provide you with technical support through the safety reviews, and they will take over from when you have the CubeSat in Japan. So from there, they will take it, they will send it to the US for the launch, and then they will set it on to the J-SSOD deployer and have it deployed. So all of that costs they will be doing, but anything related to the development of your CubeSat, no, it will be from your country, from your organization. Are there any other questions that I have missed? I see some people. Yeah, Yoshizaki-san, please go ahead.
There is a question about space law. Who are the launching states in case of KiboCUBE launched satellites? We have different actors: CubeSat owner, KiboCUBE, and the launcher, and the ISS. And I really didn't understand the meaning of this question.
To be honest, the launching state part is something I can't answer as well. I can ask my legal colleagues and put it up as FAQ on our website. But it's not a clear-cut answer, is what I know. But I will address that later on. Meaning, I will ask my legal colleagues, and we will get back to you. Sorry. Are there any special custom clearances permits provided by JAXA for the CubeSat? Maybe Ms. Yoshizaki or Mr. Fujita from JAXA can explain. I don't think there is any special custom clearance for this, but
I don't think so. Fujita-san, do you know anything about this?
I think through the usual clearance of custom export license or something, almost not special license. Okay.
okay, another question is the TRL level. Is there a certain TRL level for the components for the CubeSat? I'd like to address this question to JAXA.
Fujita-san、TRL レベルについて何か言えますか？
Sorry, what question? There will be component at different level within your CubeSat. For instance, for key subsets such as LCS, you might want to use for this TRN, but maybe the purpose you mentioned.
Maybe
Okay,
my colleague Natalie has answered it in the chat as well, but yeah, sorry, Fujita-san.
Maybe so. If you want to demonstrate the component of TRL5, so okay, so it's all right. So you can demonstrate the component TRL5 using a CubeSat. Okay.
If there's any questions related to the TRL, please follow up in the chat. Would there be any chance to connect with past winners of the opportunity to ask them about their experience and submissions? Yes, if you're interested, please send us an email. We will ask the awardees if they would have the time, but most of the times they're very supportive to anyone who is submitting anything for KiboCUBE. So yeah, please let us know your interest. You can see a lot of the presentations that they've done already on our website. So please have a look at that first before you ask questions, because I think a lot of them might be answered through their presentations. So please have a look. I'm hoping a lot of the questions have already been answered in the chat. I'm sorry I haven't been able to follow all of them. Does the technical support include hands-on training using facilities in Japan as part of the training? Thank you for your question. At the moment, no. The technical support is more of during online meetings where JAXA will be asking you to submit some safety measures, safety documents, and through that there will be a lot of discussion, and I believe JAXA will also prepare lectures for you for this. So it's more of the support regarding the documentation. And of course, if you sign up for the technical consultations that we will have later on, we will have professors from UNISEC that would give you technical advice as well. But at the moment, we don't have any hands-on training. Yeah, at the moment, yeah. Okay, I'm hoping we answered most of the questions. You can keep them coming. I will answer maybe one more question, and then I think we are out of time. Okay, so the question about the emails, that's a very easy question. So if there's anything, yeah, please involve us. UNOOSA at accesstospace@un.org. It would reach me and my other colleagues in the office. If there's any questions, technical, we would ask JAXA and forward it back to you. And if there's any other admin questions, we will be answering them to you directly. So yeah, please let us know. And also please answer the questionnaire form of the webinar now, and you can include questions there. And if we have a lot of the similar questions, yeah, we will be able to put up maybe a frequently asked questions FAQ document so that we answer a lot of the questions that came up from your side. So with this, I just like to emphasize one more thing. So along with KiboCUBE, we opened 2 more opportunities under Access to Space for All. They are on-ground opportunities under the hypergravity and microgravity track. One is drop test with ZARM and DLR. This is microgravity experiments at the Bremen Drop Towers in Germany. If you're interested in conducting microgravity experiments, please submit your applications. This is open until November. And it is the same for HyperJESS, which is the hypergravity experiment opportunity we have with the European Space Agency, ESA. This is also open until November. We have a webinar about HyperJESS next Monday on the 26th of June. So if you're interested, please register and join us. For drop test, we already had a webinar yesterday, but the recordings, the presentations are actually already there. And we will put up the recordings as soon as possible so that you will have access to all the material. So yeah, we have 3 opening at the moment, but also maybe I can also explain that in the future, in the late fall, we will be opening PNST, which is also related to satellite development with Japan. This is an opportunity to study in Japan for the whole life cycle of satellite development. So that will be opening later on. And also we will be opening the payload hosting initiative with MBRSC later in the fall as well. So for the satellite development track, even if, let's say, you're going to apply to KiboCUBE, there's other opportunities that you can apply to. So yeah, please have a look at those websites. So yeah, I'd like to thank everyone for your engagement, for the active questions. I'm sorry that maybe we haven't been able to answer all of them. Sorry, my chat is a bit overloaded, so I can't check all. But yeah, as I said, we will answer any questions later on in the frequent FAQ. And yeah, if there's anything, please send an email to us. And yeah, also put it in the questionnaire form as well. So with this, I'd like to end today's webinar. Thank you very much for everyone for joining in. Thank you very much to our partners, JAXA, providing this opportunity with us. And yeah, we hope to see you in future KiboCUBE Academy webinar sessions, and of course, to receive your applications by the end of the year. So good luck to all of you, and thank you for joining. Have a nice day. Bye.